Welcome back. We will now define what we will call the thermal energy reservoir or reservoir in short. The thermal energy reservoir is an idealized thermodynamic system which helps us reduce derivations. Instead of remaining in the calculus and differential domain, we can remain in the algebraic domain. We will need to go to the differential domain at some stage, but we do not have to do it now if we define and work with what we call the reservoir or the thermal energy reservoir. The thermal energy reservoir is a system such that a finite amount of heat transfer from or to the reservoir does not lead to any change in its temperature. Now, since we are talking about its temperature, each reservoir will be characterized by a temperature. For example, we can have a reservoir at say 30 degrees Celsius. We can have a reservoir at say 100 degrees Celsius, or we can have a reservoir at 0 degrees Celsius. If you want a high temperature reservoir, you can have a reservoir at say 900 degrees Celsius. In practice, we will be able to create such a system which would have a restriction on this finite amount of heat, or which would say instead of any change, it would provide hardly any change in the temperature. For example, you take a massive block of copper weighing maybe a few tons. Small amount of heat, a few kilojoules of heat being supplied to it or extracted from it is not going to significantly change its temperature, maybe a very small fraction of a degree. That is one approximation of a thermal energy reservoir. Another approximation is something which we use at home. Suppose we want to maintain something, say some medicine or ice cream at say 0 degrees C. What do? We crush ice, and that crushed ice we form a blanket around whatever is to be kept cool, kept at 0 degrees C. Okay. Some amount of heat transfer to the ice or from the ice will melt some ice or will freeze some water into ice, but so long as it is exposed to a pressure of 1 atmosphere, that ice and molten water mixture will remain at 0 degrees C. So, using such tricks we can create, if not exactly in an approximate sense, thermal energy reservoirs. The symbol for a thermal energy reservoir would be something like a tray, not necessarily upwards in any direction as useful, and it will be represented by the temperature of that reservoir. For example, we could have a reservoir at 0 degrees C. We could have another reservoir at 100 degrees C. We could have a very hot reservoir at say 1000 degrees C. Okay. The advantage of a reservoir is you take some amount of heat Q out of it or supply to it, the temperature is not going to change. So, we do not have to worry about how the temperature changes when some amount of heat is extracted. Okay. And hence, from a differential domain, differential calculus domain, we will remain in the algebraic domain. That is the advantage of a thermal reservoir. Thank you.